Imagine a future where humanity's reach extends beyond our planet, where the moon becomes not just a symbol of ambition, but a stepping stone for even greater journeys. In recent years, these dreams have edged ever closer to reality, fueled by bold ideas, technological breakthroughs, and a renewed passion for exploration. Today, we journey through some of the most fascinating frontiers in space science. The prospect of redirecting an asteroid toward the moon, the challenges of raising the first Mars babies, and the profound experience of absolute stillness in the vacuum of space. Let's start with an idea that might sound like the plot of a science fiction epic, aiming an asteroid at the moon. But this concept is more than a flight of fancy. It's a topic of serious discussion among planetary scientists and engineers. Redirecting an asteroid to impact or orbit the moon could serve multiple purposes. One possibility is to study the mechanics of impacts in a controlled way. By carefully choosing the size and trajectory of the asteroid, scientists could analyze how lunar geology responds, offering insights into both planetary defense and the history of our solar system. But the potential doesn't stop at scientific curiosity. There's a growing interest in the idea of mining asteroids for resources, extracting water, metals, and other materials that would be difficult or costly to transport from Earth. Redirecting an asteroid to lunar orbit, or even to the surface itself, could turn the moon into a natural way station for deep space missions. The moon's lower gravity makes it an ideal launch pad for missions to Mars and beyond, and having a ready supply of raw materials nearby could dramatically lower the costs and risks of these ventures. Of course, the logistics and safety of such an operation are daunting. Every detail must be meticulously planned. The slightest miscalculation could have catastrophic consequences. Planetary defense experts are already developing technologies for nudging asteroids away from Earth, using kinetic impactors, gravity tractors, or even focused solar energy. Repurposing these technologies for targeted redirection toward the moon would require unprecedented precision and international cooperation. The recent advancements in NASA's Artemis program, which aims to return humans to the lunar surface, could provide an essential infrastructure for such missions, positioning humanity to manage both the potential and the peril of these celestial maneuvers. As we look beyond the moon, the questions become even more profound. What would it mean to establish a human presence on Mars, not just as visitors, but as settlers? And what challenges would await the first children born on another world, the so-called Mars babies? The dream of colonizing Mars has shifted from the realm of fiction to a concrete goal, with private companies like SpaceX and national agencies alike developing technologies for interplanetary travel. Yet the reality of life on Mars remains daunting. The planet's thin atmosphere offers little protection from cosmic radiation. Temperatures plunge far below freezing. Resources like water are scarce and must be meticulously managed. For adults, these conditions are hazardous. For infants and children, the challenges multiply. A key concern is the development of robust life support systems. The air must be breathable, the water clean, the food nutritious and reliably produced. Even more critically, the environment must be shielded from radiation, which poses severe risks to developing bodies and brains. Engineers are exploring habitats that can be buried beneath the Martian regolith, using the soil itself as a shield, while biologists work to understand how gravity, just one-third that of Earth, might affect growth and development. But the technical challenges are only part of the story. The psychological and ethical dimensions are equally complex. What responsibilities do we have to potential Mars babies? How do we ensure their well-being, both physically and emotionally, in an environment so far removed from Earth's nurturing embrace? The isolation of a small crew, the lack of familiar sights and sounds, the absence of a natural environment, all of these could affect the mental health and cognitive development of children on Mars. Recent discussions in the scientific community have emphasized the importance of understanding the psychological impacts of long-duration space travel. Studies conducted in analog environments on Earth, such as the isolated research stations in Antarctica or the simulated Mars habitats in remote deserts, suggest that even highly trained adults can struggle with the challenges of confinement, monotony, and separation from loved ones. For children, especially those born into such conditions, the need for social interaction, sensory stimulation, and emotional support is even greater. Addressing these needs will require not just technology, but compassion, creativity, and careful planning. This brings us to the third theme: absolute stillness. The vacuum of space is not just silent, it is utterly still, a realm devoid of the familiar sounds and sensations that define life on Earth. For astronauts, this stillness can be both awe-inspiring and unsettling. On the one hand, it offers a profound sense of solitude, a chance to reflect on our place in the cosmos, to experience the universe in its rawest form. On the other, prolonged exposure to this sensory deprivation can have subtle but significant effects on the mind and body. Recent research has focused on how isolation and sensory deprivation impact cognitive function and emotional well-being. In the silence of space, the absence of background noise, wind, water, birdsong, can make even the smallest sounds seem amplified. Over time, the lack of sensory input can lead to changes in perception, mood, and memory. Some astronauts describe a heightened sense of awareness. Others recount moments of disorientation or anxiety. These experiences are not just curiosities. They are critical to understand as we prepare for missions that will take months or years, with crews living and working in confined spaces far from Earth. Addressing these challenges requires a holistic approach. Engineers are experimenting with artificial environments that can simulate the sights, sounds, and even smells of Earth. Psychologists are developing new techniques for supporting mental health, from virtual reality to telemedicine. And mission planners are rethinking the very structure of space missions, emphasizing teamwork, communication, and resilience. As we stand at the threshold of a new era in space exploration, these questions remind us of both the promise and the complexity of our ambitions. Redirecting asteroids, raising children on Mars, and confronting the absolute stillness of space, all of these endeavors demand not just ingenuity, but wisdom. They challenge us to think deeply about what it means to be human, to care for one another, and to shape our destiny among the stars. With each step forward, we carry the hopes and dreams of our species. The journey will not be easy, but it will be extraordinary. And as we gaze up at the moon, at Mars, and into the silent depths of space, we are reminded that the greatest adventures always begin with a single daring idea.